Hello and welcome. Today, we'll be exploring grounding systems, a key element in ensuring the safety and performance of electrical installations. Grounding systems protect both equipment and people from electrical hazards, with several methods available. Let's dive into the characteristics and selection criteria of each type to understand which grounding system best fits different environments. 1. Overview. Brief introduction. Grounding systems are essential for enhancing the safety and performance of electrical installations. The primary purpose is to protect equipment and personnel from electrical hazards, such as leakage currents and lightning. Grounding systems can be divided into isolated grounding, common grounding, and integrated grounding, each chosen based on installation environment and needs. Isolated grounding. Definition. Isolated grounding involves installing a separate grounding electrode for each piece of equipment that requires grounding. This method reduces electromagnetic interference, EMI, and is advantageous for protecting sensitive equipment. System diagram. The system diagram shows separate grounding electrodes connected to each piece of equipment, such as transformers, communication devices, and control systems, emphasizing an independently isolated structure. Characteristics. 1. Requires adequate spacing between grounding electrodes, typically 20 meters or more. 2. Considers human safety by accounting for touch and step voltage. 3. Provides independent protection for each device from surge currents. 4. Suitable for protecting equipment sensitive to noise or EMI. 5. Requires more space and can increase costs due to the installation of individual grounding electrodes. Common grounding. Definition. Common grounding is a method where multiple systems, such as high voltage, low voltage, and communication systems, share a single grounding electrode. This approach is economical and saves space, making it popular in urban areas. System diagram. The diagram shows multiple pieces of equipment connected to a single grounding electrode, indicating that all equipment uses the same grounding point. Characteristics. 1. Equipment does not interfere with each other, including electrical systems, communication equipment, and lightning protection systems. 2. Ensures even potential distribution among grounding electrodes. 3. Fewer grounding electrodes make it economical. 4. Requires precautions for high voltage surge risks. 5. Provides low grounding resistance, enhancing safety and stability. Integrated grounding. Definition. Integrated grounding combines the advantages of isolated and common grounding, reducing electrical interference while enhancing safety. It creates a common grounding network by connecting all metal parts that people can touch to an equipotential bonding system. System diagram. The diagram shows all equipment, such as electrical installations, communication equipment, lightning protection systems, water pipes, and gas pipes, connected to a common network. Characteristics. 1. Forms equipotential bonding for all conductive parts, maintaining grounding resistance below 10 ohms. 2. Requires safeguards against potential rise hazards. 3. Damage to the grounding electrode can impact all connected systems. 4. Fewer grounding electrodes are required, making it the most economical option. Conclusion. Comparison of grounding types. Summary. Isolated grounding is well suited for protecting equipment highly sensitive to electromagnetic interference, but requires more installation space and higher costs. Common grounding is economical with lower installation and maintenance costs, though it may pose some risk of interference. Integrated grounding combines the benefits of both systems, providing optimal safety and cost-effectiveness, especially for large buildings. Each grounding method should be appropriately selected based on the installation environment and requirements to ensure maximum safety and efficiency. This structure explains the characteristics, advantages, and disadvantages of each grounding type, helping to select the most suitable grounding method for the installation environment.